In this video, we will examine the inheritance of sex-linked genes. Sex-linked genes are genes that are located on either sex chromosome. Most sex-linked genes are on the X chromosome. There are very few on the Y chromosome, so we will focus our efforts on the X chromosome. Because they are located on a sex chromosome, these types of genes show distinctive patterns of inheritance. Let's look at an example. Let's say for an example we have a dominant trait and a recessive trait that are found on the X chromosome. We will use the same symbolism that we've used before with codominant and incompletely dominant traits. But this time we will use X's and Y's as the allele basis. So a dominant trait would be X big A, and a recessive trait would be X little a. For males, we will still use a Y to exhibit that Y chromosome, but in this case, the Y has no allele on it, since this is an X-linked trait, one found only on the X chromosome. So let's cross a female who is heterozygous for the trait with a male who has the dominant allele. Notice that the male only has the one allele, as we mentioned before. The Y chromosome does not carry the allele. For this reason, we call males hemizygous. That means they are basically half zygous, for lack of a better way of putting it. So let's go ahead and set up our Punnett square just like we would in any cross. And we'll put the female's gametes here, which are represented by the chromosome with the allele. And we'll put the male over here. And then we'll fill it in just like we would ordinarily. Notice we do get a 3-to-1 ratio of the phenotypes. But notice also that only males exhibit the recessive phenotype. This is typical of most sex-linked traits and certainly of all Y-linked traits. There can be a situation where a female would exhibit an X-linked trait, and let's take a look at that. If we take a female who is heterozygous again, cross them with a male who carries the recessive allele and therefore expresses the recessive phenotype, we will see that once we do the Punnett square and the cross, that we will get females exhibiting the trait. So let's put the female's gametes here and the male's gametes here. And then we'll fill in Punnett square like normal. Notice now we have one female and one male that both exhibit the recessive phenotype. This is typically rare, but it can occur when we have a cross where the female is heterozygous for the trait and the male carries the recessive trait.